Faraday waves were discovered by Michael Faraday, who was one of the genius physicists. You may have heard him in the sense of he did a lot of electromagnetism sort of work. He also did other random experiments, one of which he took this tray full of water, put it on top of some vertically oscillating thing, and vertically oscillated the water, and all of a sudden these neat patterns started forming. So I performed my experiment. I set up a speaker on the ground, and then I suspend a tray on top of it, and the tray is filled with water. And so then directly above it I place a camera, and almost directly above it I shine a really bright light so I can see the highs and lows of the waves. And the camera takes a picture, and then I get this really neat pattern of waves, because when it's vibrating in the actual tray, it kind of changes. And sometimes there's nice square cells, and sometimes they're octagons, sometimes they're circles, etc., which I think is the coolest part of the experiment, is watching these things form. So this image is the picture just imported into Mathematica, and so what Mathematica does is it creates a little matrix. You see the bright yellow is a very high wave, and the dark orange is a low wave, and so from that you can see the peaks and troughs of my wave pattern. So this image is the Fourier transform of the waveform you saw before, and a Fourier transform is a very clever mathematical trick came up with by Fourier, and basically what it does is translate real space into frequency space. If you have a regular wave that's bouncing up and down, it's vibrating at a frequency, and you take the Fourier transform and you get one big peak at that frequency, and so it allows you to understand exactly what frequencies are involved in vibrations. And so here we see the Fourier transform of that image, which at first looks like it contains nothing, but you see an interesting ring forming in the corner there. We can chop out the really low valued numbers and just look at the high valued numbers. And so this is the Fourier transform image chopped, so we only see the high valued numbers, and as you can see we get a very beautiful ring form signifying that there is a frequency that we're seeing in that photograph. My thesis advisor is David Latimer. He's a visiting professor at Reed. He's been excellent, very knowledgeable. He's willing to help me read articles, help point out interesting facts. When I'm writing up my theory, if there's some odd matrix calculation I can't figure out, he's very willing to sit down and explain it. I meet with my advisor at least once a week, but his door is always open and I'm able to run in and ask a random question or run in and talk even not about physics. And so it was super motivating, and as soon as I actually got started, the ball just kept rolling. My name is Alison Saunders, and I am a senior physics major here at Reed, and the title of my thesis is Good Vibrations, a visual investigation of Faraday waves.